Hi and good day to all students. So we move to the new subtopic 1.4 definite integrals. So at the end of this lesson, so students should be able to use the properties of definite integral. Okay, previously we have learned about indefinite integral, so now definite integral. So for the next thing, we are going to solve these definite integrals. Okay, and then part C. Okay, this is under application of integration, which is we are going to find the area of a region bounded by a curve and the x-axis or y-axis by the two curves, and also by a line and a curve. And for the next video, we are also going to learn on how to determine the volume of a solid of revolution bounded by the same thing as above. Okay, now we look at the properties of definite integral. For A, so we have lower limit A and the upper limit B. So C is a constant, so we just do a B minus A. For part B, we have two functions. We have two functions here, which is fx and gx. So we do the algebraic operations, okay, either addition or subtraction operation. So we just separate them up into fx plus minus gx. For C, okay, the same thing. We are taking out the constant C, and then we just leave the function here to be integrated. For part D, okay, we have the same limit for upper and lower, so we know that a minus a is a 0, so the integration would be equals to 0. E, okay, so if we look at these two limits, okay, here we have a to b, okay, from limit a to b, but on the right side here we have b to a. So the property saying that, okay, we just put negative over here, okay, then they are equals to each other. For the next is a f. So now we look at a lower limit to the upper limit c. So now we have, okay, we could split them up into two functions, okay, so which is from a to b and then from b to c. Okay, the most important thing here, okay, you must see the lower limit, okay, the beginning limit must be a and until up to limit c, okay, and then the limit here so must be the same limit. So please remember, if you want to split your limit, the limit here must be the same, okay, the blue one, and then you must see also the beginning and the ending point of the limit also must be equals to the original limit. Okay, and then the last one, okay, we have g. If the function is greater than or equals to 0, whereas, okay, b is greater than a and then c is greater than b, so mid of from a to b of that function also must be equals to 0, must be greater than equals to 0. Okay, so now example 12, given integration 2 to 5 of the function is a 5, and then 5 to 8 of the function is a 10, and then limits 2 to 5 of the function g is equals to 6. So evaluate each of the following. So now a, so we are doing a, so limit 2 to 5 3 fx dx, so equals to, so in integration, okay, we should always take out the constants, okay, for easier operation. So now I am taking out the 3, so the limit left is a 2 5 of the function dx. So as given in the question, so 2 5 function dx is 5, so the answer is 15. Next, b, okay, from lower limit 5 to 2. Okay, so this is quite confused. Okay, we know that the lower limit must be smaller than the upper limit. So now this question asking from 5 to 2. So now we are using the properties that we just learned from 5 to 2 of the gx dx. So we could change the properties 5 to integration of gx dx also equals to, so we are beginning, okay, we begin from 2 to 5 of the gx dx, but we must put the negative. So now negative, and then the integration to 5 of gx dx given in the question is a 6. So this is the answer. So now we look at part C. Okay, we have limit from 2 to 5 of the 2fx plus 3gx dx. So now we just break them up into 5 to fx dx plus, so another integration 2 to 5 3gx dx. So as usual, okay, take out the constant 2 to 5 plus 3 2 to 5 gx dx. So we take from the question given, so 2 of integration of 2 5 of the function dx is 5 plus 3. So from the question given, the integration 2 to 5 of the gx dx is 6. So 10 plus 18 is 28. And then for part D, okay, we have lower limit 2 to the upper limit. So clearly from the question, okay, we could see there is none about from lower limit 2 to 8. So what we must do is we are using the properties. Okay, the beginning point is from 2, the lower limit, and the upper limit is 8. We could extend the function into from 2 of the function dx plus, okay, the upper limit given in the question is 8 of the same function. Okay, so now we look at here. So the lower limit 2 and the upper limit 8, okay, the same as the question. So we look at the question, we are only have here, we have 2 to 5, 2 to 5, and then 5 to 8. Okay, so now we choose the same limit here, 5 and 5, because this is the only limit, okay, given in the question. So 2 to 5 fx dx is 5 plus 5 to 8 fx is 10. The answer is 15. Okay, now example 13, evaluate each of the following. So part A, so we're going to integrate the exponential function. So we have definite integral from the lower limit 0 to 2, okay, to integrate exponent to the power of 4x minus 2 with respect to x equals, okay, integrate exponent is we copy first, so exponent to the power of 4x minus 2 over, okay, divided by the derivative of the 4x minus 2 is a 4. So previously, okay, so we usually put plus c over here, but since this is a definite integral, so we put square bracket, okay, from lower limit 0 to the upper limit 2. Okay, so now we are going to substitute the upper limit 2 and also 0 into the solve integrate here. So exponent 4 2 minus 2 over 4, so subtract with exponent 4 0 minus 2 over 4. It's going to be exponent 8 minus 2 is a 6 over 4 minus exponent 0 minus 2 is a negative 2 over 4. So I could just simplify the solution, the answer, into exponent power of 6 over 4 minus 1 over 4 exponent squared. Okay, for next question, okay, for B, so now we have 2x power of 3 divided by the square root of 1 plus x power 4. Okay, so I believe that all of you have learned about the method of integration. So this function, okay, could not be integrated straightforward. So we must choose the correct method, which is substitution. Okay, because clearly from here, okay, I could see 1 plus x power of 4. When I differentiate, it becomes 4x to the power of 3. Okay, so let's get started. So here is a 0, 2, 1, 2 x power of 3 over square root 1 plus 4 dx. Okay, so now I use the method of substitution. So I'll choose u. So u equals to 1 plus power of 4. So when I differentiate, okay, it becomes 4x power of 3 dx. Okay, so look at to the original question. Okay, we have here 2x3 dx. Okay, here I have 4x power of 3 dx. So how to make it into 2x3 dx? Okay, so 2x3 dx equals to du over. Okay, so now we are going to substitute all of this thing into the question. So you would have equals to 0 to 1. Okay, 2x3 dx is a du over 2 is a du over 2. So here is a 1 over. So square root 1 plus x power 4 is a u. Okay, to make it easier to solve. Okay, so I put constant to the front, so it becomes 1 over 2, 0 to 1. Okay, so now to make it easier, okay, so we put the constant 1 over 2 to the front, so it becomes 1 over 2, so integration 0 to 1, 1 over third u, so I just put here u, okay, to the power of negative 1 over 2, okay, for me to easy to integrate later, so du. Okay, so now we will integrate 1 over 2, so integration of u negative half is a u to the power of half. Okay, so u negative half plus 1 is a half over half, 1 over 2. Okay, so plus c, so plus c we are going to use the upper and lower limit. First I put here c first, so because I want to integrate this, so cancel out these two. So now the answer is u to the power of half. Okay, so now I change back u. U is original in the function x is 1 plus x to the power of 4. Okay, to the power of 1 over 2. All of this, so which means the square root of 1 plus x to the power of 4. So limit from 0 to 1 is square bracket. So now, okay, so we do a subtraction. So 1 plus 1 to the power of 4 square root, so minus 1 plus 0, okay, to the power of 4, which is 0. So please remember, okay, students, this method is a very important method, okay, which is a substitution method. Important steps. Sorry, I mean this method. Okay, in the examination, okay, you must do this method. Okay, it's a must. So the last answer, the final answer is a third 2 minus 1. Alright.